All right, this lesson is on the introduction to normal distribution. So in this chapter, we're going to consider symmetrical bell-shaped distribution curves. So this would be what a bell-shaped curve would look like. It's called the normal distribution curve. Normal distribution arises in nature when many different factors affect the value of the variable. So for example, consider the apples harvested from an apple tree. Do they not have all the same weight? So these are all our apples. Some are smaller, some are larger. They might have some issues with genetic factors, soil, the amount of sunlight, etc. So here in this bottom section, if you'd like, you can pause and read some of those examples of when normal distribution would be a good choice. All right, so we're going to move on now to a little bit more defining of the normal distribution curve. So although all normal distributions have the same general shape, the exact location and shape of the curve is determined by two things. The mean, which if you remember is your average of your variable, and the notation we use for mean is called the mu. That's how you say it, is mu. That's your mean, which represents the center of the distribution. So if this is our normal curve and we drop down, this is your mean or your average in the center. The other important piece is called standard deviation. And this is the symbol we use. And what it refers to is the measure the spread of the data. So the larger the standard deviation, the more spread out the data is. The smaller the standard deviation number, the closer the data is. So in this blue box, if x is a normally distributed random variable with a mean of and a standard deviation of, this is the notation that we use. So these are the two parameters. This is your mean and your standard deviation. So our normal curve is symmetric, so it's equal on each side. Around that vertical line, x equals the mean. All of the values for the function are positive numbers. And the x-axis is your horizontal asymptote.